Welcome to this channel. My name is Mwalimu Sam Nyamu. If you are new here, consider subscribing so that you don't miss out on important videos when we upload. In our today's lesson, we shall be looking at a problem on X-rays, or simply the calculations involving X-rays. And we have this question that I want us to do together. After that, we will have another set of a question that you can try and post your answers in this platform so that I am able to get back and see if you actually got them. And in case there is a problem, I can always check from the comment section and come back and do them on the same platform. The question is as follows. An X-ray tube is operated with a potential of 50 kilovolts. Like you can see, we have a current of 15 milliamperes, and then there are a set of questions that you're expecting to get. You can pause the video for a moment and then copy this question so that now we can be able to do it together. These are the parameters that you're given. You have the potential difference or the voltage, which now you convert into voltage and get 5.0 times 10 to the power 4. You have the current. You also have the efficiency of the X-ray production. You have the charge, and you also have the mass of the electron. So the first question is determine the rate of energy conversion, and in this case, in simple terms, you're being told to compute for power. Now the formula for power is power equals voltage times current, and because you already have the values, you just substitute them and then feed them to your calculator, you end up getting 750 watts. The second question is on kinetic energy of electron, and we have the formula. Kinetic energy is given by the electron volt. Substituting the values that you already have and feeding them into the calculator, you end up now getting 8.0 times 10 power negative 5, 15 joules. The next question is on velocity of the electrons. And remember that kinetic energy is also given by half mv squared, and we have already computed for the value of the kinetic energy in the previous question. So in this question, if you're trying to now get the V, it's just a matter of rearranging the formula, and then you get the V can also be given by the square root of 2ke divided by the mass. And if you substitute this into your formula, you end up getting now this value, and then the simplified value now gives you the velocity of the electron as 4.19 times 10 power 8 meters per second. You can always pause the video in case you feel like I'm too fast, and always rewind to catch up with my speed. And the next question is the frequency of the X-ray. You know that the energy is usually given by H multiplied by F, where H is the Planck's constant and F the frequency. If you rearrange now that formula, you end up getting that frequency is given by the energy divided by the Planck's constant. And if you substitute this on now and then feed it to the calculator, you end up getting this as your answer. Next is the number of electrons. We know that charge is given by current multiplied by time. And in our question, we aren't given charge. We don't have time, but it is important to note that you're already given the current and the charge per second. Remember, it's also equivalent to current. With that now in mind, we can agree that because in the question you're already given the current as 1.5 times 10 power negative 2 amperes, it is equivalent to the charge per second, which now makes our charge equivalent to 1.5 times 10 power negative 2 coulombs. Now with that, we know that the charge is also given by the number of charges multiplied by the charge per electron, this particular formula. So making n the subject of the formula, number of charges can also be given by charge divided by the charge divided by the electron charge, the charge for a single electron. So the quantity of charge divided by the electron substituted into a formula gives us n as 1.5 multiplied by 10 power negative 2. They divided that now by the charge per single electron now, which is 1.6 times 10 power negative 19, and feeding in your calculator, you end up now getting the number of charges as 9.375 times 10 power 16 electrons per second. This is the takeaway assignment. Look at this question, attempt it, then give your answer in the comment section connected to your admission number so that I'm able to check, see if you're getting it, and then from there we can always I can always get back and explain in case I find that you're having challenges on it. Until next time, I remain Mwalimu Sam Nyama.